Now let's finish looking at section 1.1. There's a few more definitions I want to go over today, but they're a little bit different than the last video, so I thought it'd be good to take a break and look at them fresh now. So the other thing we're going to talk about are the branches of statistics. There's two main branches of statistics. You have your descriptive statistics, and think about it. Descriptive means to describe, right? So usually those are your calculations and things like that. And then you have your inferential statistics. And when you make inferences about things, you are looking for patterns or trying to figure out what could happen or what's really going on as a whole. So we have two different sides of things. We have the actual physical data, right, that we collect. Those are your descriptive statistics. Those are known. And then you have your inferential statistics. So when we're trying to then take that data and apply it to the whole population or apply it to a whole idea or try to make predictions about something. So we're inferring about what is going on or kind of guessing, taking an educated guess at what's happening. So descriptive statistics is the branch of statistics that involves organization, summarization, and display of data. Inferential statistics is the branch of statistics that involves using a sample to draw conclusions about a population. A basic tool of inferential statistics is probability. So we're going to see more about probability in chapter 3. Okay. So descriptive statistics are the actual data, the actual calculations that you know to be true based on that sample or that population. Your inferential statistics is when we take an idea, so we look at that data and we try to take a guess at what's going on overall. So we often use our sample data to try to understand the entire population, right? So for instance, let's say at the end of the semester, let's say you do your course evaluations for my class. Again, usually not everybody takes them, although I'd love it. Right? It'd be great to have population data, but usually that doesn't happen. But I would take my sample of those who filled out the course evaluation, and then I would infer about how the overall class went. Now, I know I don't have everybody's opinion there, but I'm using the opinions that I have to get an overall picture of the class, right? So that is inferential statistics. So for each study below, we're going to identify the population and sample, so a little bit more practice there, and then determine which part of the study represents the descriptive branch of statistics, and then also what conclusions might be drawn using inferential statistics. So first we see a study of 2,560 US adults found that of adults not using the internet, 23% are from households earning less than $30,000 annually. And there's actually a figure on page 5 in your text that you can look back on. They have a nice little graph there. So you can feel free to check that out. So first thing, let's see, we're going to do the population and the sample first. So notice I have a study of 2,560 US adults, right? So that's our sample. Okay. And then the population would be all US adults, right? So they took a sample of US adults, but not everybody. So the population would be all US adults. So then we're going to figure out what is the descriptive statistics, or what are, and then what conclusions may be drawn using inferential statistics. So what conclusion are we going to draw here? So for our descriptive stats, we see a few things, right? So first of all, we see how many people were surveyed. But the big thing here is the information that we obtained from that survey. So 23% are from households earning less than $30,000 annually. And these are people who are not using the internet. Okay, so we surveyed all these people, then we focused on those who don't use internet at home. And we found out that 23% are from households earning less than $30,000 annually. So these are the descriptive statistics, right? So this is the exact information that we were able to pull from that survey, the actual data. So we were able to find that 23% don't use internet are from households that are earning less than $30,000 annually. So what can we infer from that? So what do we infer, or what do we think that this could mean, right? Now, there could be different conclusions here, but one way to express it is that a possible inference could be that lower income households cannot afford access to the internet. So this is a possible conclusion that we can get. So we see that for those who are not using the internet, 23%, which is pretty high, are from households that earn less than $30,000 annually. So that for a household is a small amount of money, right? So one inference could be that maybe people who don't earn, who earn lower income, maybe they can't afford the internet. Now, again, this is an educated guess, right? So for inferential statistics, we do the best we can, but it is an educated guess. It doesn't mean that there's not something else going on here that maybe we need to look into a little bit further. So let's try another one. A study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. All right, so first of all, what is our sample? So we see the study was of 300 Wall Street analysts, and they were predicting or forecasting high-tech earnings. Okay, so our sample would be the 300 Wall Street analysts who, I should say forecast, not predict, so forecast high-tech earnings. So that's our sample. So the population would be all Wall Street analysts who forecast high-tech earnings. Right, so when we talk about Wall Street, there's lots of different stocks, there's lots of different companies. So these are analysts who have forecasted high-tech earnings. So those who are in the high-tech industry, okay? So our sample of the 300 ones we looked at, but the population would be any Wall Street analyst who makes forecasts in the high-tech industry. So what is our descriptive stats? Well, our descriptive stats would basically be this 44%, right? So 44% incorrectly predicted or incorrectly forecasted the earnings. So this is our descriptive stats. So remember, they describe, they're the actual numbers that we compute using the data. So what could we infer here? And again, there's different inferences. So we're just using one little tiny piece of data. When we're actually doing real statistical surveys, that we're using much more information, right? So we should be looking at this from a bigger perspective and thinking about other variables that come into play here. But one inference could be that the stock market is difficult to predict even for professionals, right? So if we see that 44% in this sample forecasted incorrectly what was going to happen with those high-tech earnings, then one inference we can make is that the stock market is difficult to predict, even for professionals. So almost half got it wrong, and that's their field, right? And obviously they want to be right because that's how they get money, right? And you earn money by being correct in your predictions on, where to buy and what to sell and all that stuff. So That could be our inference here. All right, one last example. A study of 1,000 US adults found that when they have a question about their medication, 3 out of 4 adults will consult their physician or pharmacist, and only 8% visit a medication-specific website. So, first of all, what is our sample? Okay. So, the study of 1,000 US adults. So, our sample would be these 1,000 US adults who were studied. And our population would be all US adults, right? Everybody. So they found out that when they have a question about the medication, 3 out of 4, so 3 out of 4, 3/4, will consult their physicians, and only 8% go to a website. So this right here, these are our descriptive stats. Okay, so it's the actual calculations that we get from the data. So 3 out of 4 people said if they had a question on medication, they're just going to go right to their doctor or pharmacist and ask them directly. Whereas 8% said that they would look at a website instead. So that's our descriptive stats. Now, from those descriptive stats, we try to see, well, what's actually going on. So what could we infer here? And again, it's an educated guess. And we're using just very little information. So keep that in mind, right? Normally we'd have a lot more information if we're actually trying to make a prediction or a better educated guess. But one thing we can infer here would be that most people, right, because it was 3 or a 4th, that's most people, ask their doctor or pharmacist if they have a medication related question. Right, so some go to the website, right? Websites are still good. We want to have those there, but looking at the data, we see that most people are probably going to go directly to their doctor or their pharmacist if they have a question. Okay, so again, just a little bit more about what kind of stats we can look at and how we're going to take this throughout the course. We have a lot of work to do first on how to actually calculate the different, the descriptive stats, excuse me, and then how to actually go to the inferential stats and make predictions. And it's not just guessing. So again, we're kind of just guessing here, making an educated guess. That's part of it, but there's also math that goes with it too, to let us know how strong our guess is, right? So are we pretty sure that our guess is true, or are we not so sure? So there is a lot that goes into it, and we're going to explore both of those fields throughout the 15 weeks in our course.